So good morning to everyone. So this is Dr. Kausar, Unnisa, Assistant Professor, Department of Commerce and Management, GFGC, KGF. So in this session, let us go for having a discussion on Unit 3, that is the measures of central tendency, and also the problems on the calculation of mean and individual series. So we know that usually when two or more different data sets are to be compared, it is necessary to condense the data. But for comparison, the condensation of data set into a frequency distribution and the visual presentations are not enough. So it is then necessary to summarize the data set in a single value. Such a value usually somewhere in the center and represents the entire data set, and hence it is called as the measures of central tendency, or it can also be called as averages. Since a measure of central tendency or nothing but an average, which indicates the location or the general position of the distribution on the x-axis, it is also known as the measures of location or a measure of position. So we know that a measure of central tendency is a summary statistics that represents the center point of a data set. When these measures indicates most value in the distributions where it is going to be fall, and also referred to as the central location of a distribution. A given raw statistical data can be condensed to a large extent by the methods of classification and tabulation, but this is not enough for interpreting the given data. So we should depend on some mathematical measures that is called as a measure of central tendency. So a measure of central tendency is an important aspect of quantitative data, and it is an estimate of a typical value. So in statistics, the central tendency is nothing but the descriptive summary of a data set. To a single value from the data set, it reflects the center of the data distribution. So it does not provide the information regarding the individual data from the data set, where it gives a summary of the data set. Generally, the central tendency of a data set can be defined by using some of the measures in statistics. And then we know that what do you mean by central tendency. Central tendency is nothing but, you can call it as an average or a central location or the measures of center. Or it is nothing but a summary of the measures that attempts to describe the whole set of data in a single value where it is representing the center of its distribution. Let us will see some of the definitions of this central tendency. So according to the Croxton, he is going to define the the average or the central tendency is nothing but an average value is a single value within the range of the data. It is used to represent all the values in the series. So since an average somewhere within the range of data, sometimes it is also called as the measures of central value. So very clearly we can able to say that a central tendency is nothing but the average value or a single value which is representing the whole set of data in the range of the data set which is going to be given. So that is called as the central tendency. Let us see for what purpose we are going to prepare this. We are going to calculate the central tendency means. What are the objects? What is the purpose? The purpose of these averages is nothing but to present the complex data in a concise manner. We know that the data, when it is very difficult to analyze it, to present it, or to express the things, if the same data, if you are going to present in with the help of a single digital value or with the help of single value that is called as an average, So it is very easy to understand the complex set of data can be present very easily in a fo- in a average or in the form of central tendency. And also if you want to compare the data from one set of data with the other set, so this average also facilitates us to compare the data with the different distributions, and also to collect the mass data from the sample. So we know that we can able to assemble the data just by seeing the samples of the data. The samples of the data which is going to represent the whole set of data distribution that what we are going to be collected. For that purpose also we are going to study the central tendency. And also for decision making purpose also we are studying the averages, because the single value is representing the whole distributions. So for that reason we are going to calculate the values of averages, and also to establish the relationship between the two series. If you want to compare the series, if you want to have the relation, whether it is having the positive relation or the negative relation, with the help of these averages, we can able to study it very easily. So these are all the reasons why the central tendency are being studied. Let us will go for the next thing, that is called the essentials of a good average. When we are going to see an average means, what are the requisites or what are the essentials that should be there when it is going to be called as a good average. So the first thing is that uh, an average must be well defined, it should be easy to understand, it should be based on all the items of the series, capable of algebraic treatments, and it should be a good representative data, and should be free from the effect of extreme value. Let us will go one by one. So average is nothing but a statistical tool where it possessing some of the following characteristics or properties here. So first, when we say that a good average must be a well-defined average. An average should be rigidly defined to give the uniform result. If not, it may are going to produce the different answers, and the investigators may lead to different interpretations. See, when we are going to say an average means it should be free from everything. It should not have any complex thing to understand. It should be very accurate. It should be rigidly defined, right? It should be universally accepted. Then only the investigators or the researchers who are going to collect the information doesn't have the different opinions or different types of interpretations. And the next one is that it should be easy to understand. When we are going to calculate the averages means it should be very simple to calculate. You should not have difficult steps to understand to make it. So a common man can also can be able to understand the things and can able to calculate the averages. So when we are going to have the calculation, it should be very easy, simple to calculate, so that the researchers or the investigators should feel no difficulty during the time of determining the average value. And the next thing is that it should be based on all the items of the series. And next requisite we are going to come across that it should be based on all the items of the series. Otherwise, it will not represent the data completely. So when we are going to consider any one particular answer means the answer should reflect, or it should be based on all the distributions, or it should be based on all the entire distributions what we have been collected or assembled. Based on all the based on all the data only, the answers has to be reflected. Therefore, the good average should reflect the what should it should reflect the accurate information from the mass set of data. And the next one is capable of algebraic treatment. So this average should be capable of further algebraic treatment. It is nothing but the good average should provide a comfortable ground for mathematical analysis. Otherwise, its use and applicability will be confined to some basic needs of the investigator. For example, to define a combined mean of two or more series. So when we say that it should be go for further calculation, the average should be used for the other mathematical treatment also. Then only it is called as a good average. And the next one is that the thing is that it should be free from the effect of extreme values. A good average should not affect much by extreme values. Otherwise, different samples of the same averages gives the different results without much uniformity. Means the two extreme values means the first and the last, right? The points where we have been collected the data, it should not be affected to with these two extreme values, because if it is going to be affected with the given set or given the proper range of the data, so at that time whatever the samples we are going to be collected, so it is going to have the different results, or it doesn't have that much uniformity. So these are all the essentials of a good average. Let us will see some of the different types of averages that we are going to come across. Basically, there are five common types of the averages. One is the arithmetic mean, the second one is median, mode, geometric mean, and harmonic mean. But literally, we people are going to study only the three types of averages, that is the mean. In the mean also, we are going to have two methods. One is simple arithmetic mean, another one is the weighted arithmetic mean. So median and mode, it doesn't have any other categories. But in the examination point of view, only these three averages we are going to have under our study. But geometric mean and harmonic mean, we are not going to have under our study. So let us will go by one the type of the average. Let us will go and see this. What do you mean is this arithmetic mean? So arithmetic mean or an average is nothing but the ratio of all the observations to the total number of observations. When we are going to study about the arithmetic mean is nothing but the total number of observation, if it is divided by the number of items, then it is called as the average or mean average, or it is nothing but simple arithmetic mean. So how we are going to calculate this simple arithmetic mean means, so the total number of all the items should be calculated together divided by their number of items. We know that in the case of individual series, so individual series means whatever, it is nothing but the ungrouped data set, what we have been collected. Whatever the data we have collected, it is been represented in the same manner. So we should see that how many, the total number of all the observations what we have collected divided by the number of items. That is the value how to calculate with the help of simple arithmetic mean. It is nothing but mean is equals to sigma x by n. This is the direct method where we are going to use for the calculation of simple arithmetic mean. Let us will see some of the problems here, how to calculate the arithmetic mean and the individual series. See, these are the data which has been given here. Compute the mean marks of 10 students in statistics. Here we have to calculate what is the average marks of the 10 students. So this is the information marks secured by the 10 students in the statistics. The first student has scored 40, second one 48, third students 35, 59, 17, 92, 48, 68, 82 and 28. So these are all the variables given in the question. So what we'll have to do to calculate these things means, so we should go for total the values first. So direct method, we know that mean is nothing but sigma x by n. If you want to arrange the data in an ascending or descending order, you can able to arrange the data, because the value of mean doesn't reflect only for the case of median and mode we require the arranging of the data. But for the mean, if you like to arrange means we can, if not also we'll get the same value here. In case of mean, here we have calculated, that is mean is equals to, in the direct method, sigma x by n. So we have to add all the values. Sigma x means the total x values what is given in the question. Sigma means summation of the x variables, that is 40 plus 48 plus 35 plus 59 plus 17, 92 plus 48 plus 68 plus 82 plus 28 divided by how many student marks given me, that is by 10. So mean equals sigma x by 10. So the total of the numerator value, it is 570 divided by 10. Therefore, the value of mean, that is arithmetic mean, or the average marks of the 10 students is nothing but 57. More or less, the student have scored in the range of what? 57 marks. This is the average marks and the individual series that has to be calculated. Let us will go for the second question here. Find the average height of 6 students. See, whatever the information is given, that will become the x variables. Here the height of the 6 students are given. One student height is 163 centimeter, another one 173, 168, 156, 162 and 165 centimeter. In the same manner how we calculated under direct method, we have We apply the formula for the calculation of mean. So mean is equals to sigma x by n. So sigma x is nothing but summation of all the x values. So 163 plus 173 plus 168 plus 156 plus 162 plus 165, total together it becomes 987, divided by 6 students. So n in the individual series we know that n is nothing but the number of the number of variables, that is 6. So therefore the average height of the 6 students is nothing but 164. Total 587 divided by 6 is 164.5 centimeter. So this is how we require to calculate the value of mean under direct method. Let us will go for the third question here given. So following are the wages of the group of workers. Find the average daily wages of the workers. So here they have given the serial number for the 10 workers, and also the information given, that is daily wages. The daily wages of the first worker, is earning 25 rupees, 35 rupees, 40 rupees, 50 rupees, 30 rupees, 20 rupees, 60 rupees, 45 rupees, 38 rupees and 32. So this is the information given in the question. With this, I am going to end the